So this might shock some of you, but the Wi-Fi in my home network is actually rather old. Most of my access points are going on 6 years old now. So I'll definitely admit that a Wi-Fi upgrade for my home network is something that's been on my mind for a while. But I have pretty strict standards when it comes to what equipment I'll put in my network, and I haven't found anything so far that I feel like checks all the boxes of what I'm looking for. So today I'm taking a look at a Grandstream wireless access point. I'm going to see if it meets my requirements and may be considered for my future home network. So if that sounds good to you, then come along on this adventure. So what are my strict requirements? Basically, I've got four things I'm looking for. First off, the gear I have right now is all 802.11ac Wave 2, so that's what we call Wi-Fi 5 nowadays. And if I'm going to get something that's just basic Wi-Fi 6 or even basic Wi-Fi 7, without a lot of the new features that were added as optional in Wi-Fi 6 or Wi-Fi 7, I'm really not gaining much. Half of my clients are still basic Wi-Fi 6 compatible. I don't think I might only have one that supports 6 gigahertz. So if I'm going to replace my equipment today, it better be able to last me for another 6 years, just like my APs did past 6 years. Second thing I'm looking at is I'm looking for a vendor that has long-term support. The gear I have right now is made by TP-Link. I haven't had any problems with any of these. However, all of the models I'm currently using in my house are still on sale today, and they're new hardware revisions. So mine are older hardware revisions, and they don't tell this on their website that these are really a different unit. It's got different SoC and everything. And some of my models haven't received firmware updates in like 5 years. So I'm stuck on really old controller versions to work with these old access points, which I guess is technically okay, but it's a huge problem for me that TP-Link, while they still sell a model called the EAP225, my EAP225s are Gen 1 and Gen 2 and haven't gotten firmware updates since 2019. The third thing that I'm looking for is I want something that is cloud-free. So that could be each access point is individual. I'd prefer something that's connected together and managed solo. But for central management, that could be I host my own controller on my infrastructure. It's fine with me. Or one of the access points hosts the controller for the other ones. Either of those architectures are fine with me. I just don't want to have to rely on a cloud service to configure something so critical on my network. And the fourth thing I'm looking for is IPv6 for the management interface. So obviously these APs are going to be able to transfer IPv6 packets just fine. They're acting as essentially layer 2 bridges. But for the management interface of these networks, I want my management VLAN essentially to be all IPv6 only going forward. So the TP-Link ones can't do that. Ubiquiti can't do that. We'll see if Grandstream can do that. This model I have today to test is the Grandstream GWN7665. Let me look at the spec sheet here. This is an 802.11ax, so that's Wi-Fi 6, tri-band, so it includes 6 gigahertz, which makes it Wi-Fi 6E access point. Now disclosure, Grandstream sent me this unit for review. They sent one unit, so this is not enough to do my whole house. If I want to do my whole house, I have to buy the rest myself. But I'm just going to evaluate this one today to see if this would be a contender for my new Wi-Fi in my home network. No money changed hands. They won't see the video until you do, that kind of stuff. So let's take a look at what we got in the box. I got to go into ultra wide mode here. So I have some instructions. I'll just kind of throw those out. And I got the dish itself. So it looks fairly similar to a lot of other APs in this class. It's a dish. Let's pull it out of its bag. Looks like I've got a unique password, so every unit is unique. I like that. I don't like default passwords. So it's got some sort of ceiling bracket. I'll pull that out in a sec. Looking at the connectors down here. So the only connectors we have are both Ethernet. They're labeled net and PoE. One is 1 gig and one is 2.5 gig. So I assume I can use either one of these. I'll probably start with the 1 gig. I don't actually have a PoE switch that can do 2.5 gig PoE, but I can probably get a PoE injector for that. It's certainly got some weight to it. I'm pretty sure this is metal and this is plastic. Sure feels like it. It's very chunky. Also in the box, I got packing materials. This looks like a mounting plate, I guess, to screw onto whatever. And more mounting plate hardware. Yeah, so you screw this up into the ceiling and then the Wi-Fi AP just kind of clicks in. Looks fine. And I also got a set of screws. So I'm going to get this guy set up and move on to testing it. So I set up the Grandstream AP, replacing one of the 4 APs I already had in my house. So just put it right in the same position, hooked it up. I've got it connected to 2.5 gig, so I'm of course very optimistic about the performance I'll get, but we'll get to that later. And first off, I'm going to look at the first one of my checkboxes. That is the management interface. So for small deployments like mine, Grandstream lets you pair up to 50 access points to a single master. So the master access point runs the control software, monitoring, configuration, all that stuff, and all the slave access points get adopted to it. In this case, I'll probably end up having 4 access points in my long-term setup just like I do now. So 4 access points is well within the limit of 50, and this is the approach I'm going to take. So let's take a look what the UI looks like. So this is the UI that's just running on the GWN7665. I've configured it a little bit, but not really done much. It's accessible over this mdns.local address, so I didn't even have to figure out what IP address it found. Also, fun fact, it supports IPv6, because it got an IPv6 address and it's advertising over MDNS. So this .local connection is running over v6. And so this looks pretty much like what I'd expect. So on my main page, you can see basic information about the system. Looks like I have 4 clients connected right now. None of them on 6 gig yet. I don't actually have any 6 gig clients running, so that's kind of expected. You can see what SSIDs are popular, who's using bandwidth, etc. Moving over to the access points tab, so I only have 1. The default column list shows its IPv4 address, but I can actually go in here in the settings and add IPv6 address as a column. So IPv6 is pretty much a first-class citizen now. The AP got an IPv6 address, I can use it for normal IP things, and all the boxes that take an IP address take an IPv6. So as for configuration, I can give them names, etc. here. So I name this WAP 7 because it's the 7th WAP in my system, not including numbers 1 and 2 that I've retired. You can give it static addresses or let it find dynamically both for v4 and v6. All the other stuff is pretty normal. This particular access point has 2 network interfaces. So I can go here and change if it's a trunk port or an access port, which means if it's going to be VLAN tagged or VLAN not tagged. And if it is, I can set what PVID it's on. So this is basically configuring the built-in switch for those 2 ports here. So I've created some SSIDs just to test. I'll go through the add menu if you guys want. So we have different options for the SSID. We can get set into a VLAN, etc. So we could give this guy VLAN 69, but we can't give him VLAN 666 because that is an error. 666 is not allowed VLAN, which is fun. 69 is. For the band it's on, we can set what frequency we want. So this is a tri-band. We can also set dual band, and there's different combinations of that, or single band for this particular SSID. One thing I will say is that they require a unique SSID name for each SSID, which sounds like it shouldn't be a problem, but it's impossible to create the same SSID on different bands. So if I create an SSID that's on 2.4 gigahertz, I can't create a different SSID with a different configuration that's only on, say, 6 gigahertz with the same SSID name, because the SSID name must be unique across all SSIDs in the system. And that is very logical, except when it comes to WPA3. I'll talk about that a little bit later in the video. So if 6 gigahertz is part of your channel selection here, so if I pick 6 or 5 and 6, 2, 4, 6 tri-band, the only security we can choose is WPA3. So here our options are 802.1x EAP or SAE, which is passphrase. It doesn't support OWE, which I guess is not that uncommon. Apple doesn't support it either, although it's part of the standard. And of course, the only encryption is AES. That's the only thing allowed in the 6 gigahertz band. So that applies to 6 gigahertz, 5 and 6, 2.4 and 6, and tri-band. If I go to a mode that doesn't include 6 gigahertz, then it opens me up to some legacy authentication. So I could enable WEP. No one should ever enable WEP. I could enable WPA in, say, TKIP, RC4, which is also very insecure. But it gives me a couple other options here. So we can do traditional WPA2 with AES PSK. We can also do PPSK, or private pre-shared key. I actually have a video up here on that, and that can be done with or without radius. And I'm sure going to get some hate about this, or people that actually love PPSK without radius, etc. But this doesn't work in WPA3. So in WPA2, the client would send its last message. The access point would decrypt it using the pre-shared key, the well-known password. And so essentially what without radius PPSK does is the access point has a list of the possible passphrases you could use, and it tries to decrypt that frame over and over with its different ones in the list. And when it finds where that matches, it knows that must have been the PPSK that the client used. And SAE, the new authentication method in WPA3, requires more mutual handshaking. So the access point must prove that it knows the password before the client will add anything based on that key material. Technically, you could do PPSK with Radius in WPA3. The AP here doesn't support it. What it does support is 802.1x Enterprise Authentication, which I've also made a video about up here. Some other options in WPA2. We could enable or disable 802.11w, which is protected management frames. Usually you should leave this as required unless you have some devices that don't support it. We can do client isolation per, we could say per radio, per MAC, etc. And then some other security options like 802.11k VNR, fast roaming, etc. So once I've created an SSID, I need to assign it to each AP that's going to carry this SSID. So I could do that from the AP configuration, but I could also go here to device membership, and it looks like it's a member of this guy, but I could take him out of that one, so now he's not going to broadcast that SSID. Put it back in too, back in there. So it shows me here, each of these APs can handle 16 SSIDs per band. So this guy's got 4 2.4 gig, 4 5 gig, and 1 6 gig, and he's not quite full yet. Now, some of you are going to jump at this and say, wow, 16 SSIDs per radio. That's 48 SSIDs, that's great. Other companies only let me do 8 per radio. And while 16 per radio sounds like a big number, you never want to run more than like 3 per radio in the real world. So for each SSID you're carrying, even if it's a hidden SSID, it's still sending out beacons from the radio for each SSID separately, and they have to be sent at the basic rate. That's like 1.5 megabits per second or something crazy slow. 6 megabits I think now in 802.11n. And they take a ton of airtime because they're sent so slowly. So if you actually had 16 SSIDs per radio, remember these are all sharing one channel because we only have one radio channel per band in this AP. It's going to spend all of its airtime just sending out these really slow beacons for all of your SSIDs. So please don't do that. So moving on down to the clients page, we can see we've got different clients here. It by default shows our IPv4 address again, but I can come in here and flip that over to IPv6 and show their IPv6 addresses. So also have the usual stuff. We can set bandwidth rules. For example, I could set it to be on all SSIDs per client, limit of, I don't know, 150 megabits per second. I could do it on a schedule, or I could do it just all the time. We have the options of per SSID, per client, per MAC, per IP address, and we can also select which SSIDs it applies to. And I mentioned earlier it does PPSK, so PPSK is here. I can go set this user just a username that you use, but then I could come and set a Wi-Fi password here, and I could say how many clients, what VLAN they get assigned, etc. So you could have multiple Wi-Fi passwords, and based on what password the client typed in, they get binned into a different VLAN, or they get binned into a different upload-download limit, or they have a limit of how many clients can use that password, etc. All of those things are options. Now again, I know you guys love PPSK as a feature. I'm going to remind you again, PPSK does not work in WPA3. It is only for WPA2, and the advantages of moving to WPA3 are probably bigger than the advantages you get from PPSK. So yes, I know it's very easy to crack WPA2 passwords. Using a unique password per device fixes that, but also just using better encryption fixes that. So I don't really use a captive portal on my access point, but they have a full setup for captive portals if you're into that. So frequencies, I'm letting it auto plan my frequencies, and so far it's done a perfectly reasonable job. You can come in here and pick which channels it's allowed to use. So in most of the world, you would set 1, 6, and 11 as your 2.4 gigahertz channels. Unless you're in Australia, where channels 12, 13, and 14 are available, then you do 1, 5, 9, and 14. If you're not in a region with channel 14, which is most of you, use 1, 6, and 11. They don't overlap. So down here, they've defaulted to excluding the DFS channels, but you can come in here and include DFS channels if you want. I don't use DFS channels. Being in the US, I don't really need to, but some people might. Also a nice feature, it can do ARP and ND attack defenses. So here you can set up static IP to MAC bindings, and it will reject ARP frames that try to tell anything different, that just prevent someone from spoofing your router. In the IPv6 land, they don't have quite so much going on. They just have the source MAC consistency check. It would be nice to see that same IP MAC binding in ND as they have in ARP, but at least they have something going on for ND. And you can actually write firewall rules for the AP as well. So which SSIDs they apply to and what you're considering. Now, one of the quirks I did find was with upgrading. So to upgrade the firmware, it's looking for a TFTP, an HTTP, or an HTTPS server. And you give it the path, and from that path, it looks for a file name that is its model number.bin. So it's looking for a file called GWN7665 fw.bin at this path. And they actually don't provide that. So I had to host the bin file on an HTTP server of my own for it to upgrade. So reading their documentation, it seems like they're intending this whole setup to be used for like managed service providers. So they kind of want each MSP to be rehosting their downloads internally instead of having hundreds or thousands of APs reaching out to their CDN. It would be nice if they hosted a CDN with these firmware images. It would also be nice if their controller could host them on behalf of the other APs instead of telling the other APs to update. For me, it wasn't hard to dump this firmware image file into a server I'm already running. If you're already running infrastructure, that might be more work for you though. So, number 2 on my priority list is having a good radio. I am hoping my Wi-Fi upgrade lasts me for quite a while, as my last APs did. So I'm going to make sure the feature set of this AP is something that will carry me forward for the next couple of years at least. So I've got the spec sheet opened up so I don't say anything wrong. So first of all, this is the Wi-Fi 6 generation. So IEEE 802.11ax, which the marketing people decided to call Wi-Fi 6 because bigger is better, right? Specifically, this guy is 6E. And in Wi-Fi 6, the Wi-Fi Alliance decided that the E would mean it's enhanced to support the 6 gigahertz band. That is partially because 6 gigahertz standard came later, so they wanted to launch non-E devices, and also because the 6 gigahertz band is not allowed in many countries. So in the US, we have like a whole gigahertz of spectrum. Europe has about half as much, which is still a whole lot of spectrum compared to what we had in 5.7 gigahertz band. And outside of that, I guess you'd have to look up what your local region supports. But in those two regions, you have plenty of spectrum for 6 gigahertz. Now, confusingly, the Wi-Fi Alliance marketing people decided not to carry that E terminology into Wi-Fi 7. So I see a lot of people in comment sections of other videos about other access points talking about how, oh, this Wi-Fi 7 AP doesn't support any features. And a lot of that blame is to lie on the Wi-Fi Alliance, who very clearly marketed in Wi-Fi 6 generation when an AP did or did not support 6 gigahertz with that E. But in Wi-Fi 7, a lot of people think a Wi-Fi 7 AP is just better when it might not support 6 gigahertz at all and still be Wi-Fi 7 standards compliant. So, what features from the Wi-Fi 6 standard does this thing actually support? Because of course, like the modern HDMI and USB standards groups, Wi-Fi Alliance says bigger number is better when that's definitely not the case. This guy supports 2x2 multi-user MIMO in both uplink and downlink on 3 bands. So that's a total of 6 spatial streams. Some vendors call it like 6 spatial streams, which means 2 plus 2 plus 2. Other vendors will call it like 2x2, 2x2, 2x2. They'll call out which MIMOs they support on which bands. Some access points do actually have a different number of streams per frequency. So like they might have 2x2 in 2.4 gigahertz, but then 4x4 in 5 and 6, for example. This one is 2x2 on all 3 frequencies. That is multi-user MIMO that was added in 802.11ac. That is on the uplink and the downlink. So that's a feature that was added in 802.11ax or Wi-Fi 6 to have it on the uplink as well. It also supports 1024 QAM, that's MCS 10 and 11. Not that you'll ever be running MCS 11, even though they added even higher ones now in Wi-Fi 7, but it's there. If you happen to be sitting right next to your AP, you'll get some really high speeds. Other features from the list, what do we got? So 2.4 gigahertz, we get G, N, and AX. There was no Wi-Fi 5 in 2.4 gigahertz for some reason, but yeah. Good thing it supports G too, because I have one device on my network that's still stuck with 802.11g. That's a huge pain in the ass for me to support. So maybe it'd be cheaper just to replace the wireless sprinkler timer that times my like 20 sprinkler zones outside. But yeah, it's a pain. On 2.4 gigahertz, technically you can use 40 megahertz channels. I don't think anyone should be doing 40 megahertz channels on 2.4 gig. There's only 3 20 megahertz channels to use from, so do 20 meg and 2.4. On 5 and 6 gigahertz, this guy supports 20, 40, 80, 160. So that is not 320 megahertz on 6 gigahertz. Some devices support that. I don't know of any clients that support 320 megahertz channels on 6 gig. I think mine only supports 160 megahertz that I'm going to be testing with later. It also does not support 80 plus 80 bonded, which is not, again, a common thing that clients support anyway. It does support the DFS channels like we mentioned earlier. I don't use DFS channels. Being in the US, I have plenty of 40 megahertz, 5 gigahertz channels available. If you're in the EU, where you don't have the Uni 4 and Uni 3 bands, then you would probably want to be using a lot more DFS channels. So I think that's the key specs, at least for this guy. The most important thing is that it supports 6 gigahertz. It has 3 radios, 2.4, 5, and 6. Each of them are 2x2, and they are the Wi-Fi 6 generation. So if you were to get a Wi-Fi 7 AP, Grandstream actually makes one already, the biggest feature that comes with Wi-Fi 7 that's advertised is either 4096 QAM, which could in theory get you 4 times the bandwidth, again if you're literally right next to the AP, and also MLO, multi-link operation. So MLO lets you use more than one frequency at the same time to the same client. That has some very specific use cases that you probably won't need at your home or small business network, and some people think they need them anyway. If you are running a small business network and you do have areas with higher client density, you may want to go to an AP with more MIMO. So this one's 2x2 in all 3 bands. You could go to something that does 3x3 or 4x4 in the higher bands. It's probably not going to help you that much in 2.4 gig. The other thing you could do instead is just add more APs. So this guy only costs $110. You could just have 2 of them. So, in the land of wireless access points, many access points are now starting to include 2.5 gig Ethernet. But this begs the question, do they actually need 2.5 gig Ethernet? And also, a lot of new APs are only coming with a gigabit. And that also begs the question, shouldn't they have more if they're trying to claim like 10 gigabits per second over Wi-Fi 7? So today I've set up this Grandstream AP, it's sitting right here next to me. I've got my laptop connected to it at 5 gigahertz, and I've got this guy connected to it at 6 gigahertz. We're going to see if we can break the 1 gigabit barrier with 2 clients. Now this isn't going to happen with one client because neither of these guys can do gigabit. I don't think, I guess we'll see with this one. But yeah, let's see what happens. So this guy is connecting to a server that supports 10 gig. And we are getting, okay, 800 megabits per second, 850. Not bad. So, single client, you're still not doing gigabit, at least with 2x2 equipment. Now, of course, if you have 4x4 equipment, you could do more than gigabit. That would also require your client to be 4x4 as well if you're trying to get single client throughput. And at home, most people aren't doing like the whole hundreds of user things like small businesses or large businesses are. So I don't see anyone doing this kind of bandwidth on a home network. So we'll let this guy go at his 700, 800, 900 megabits. And here I'm looking at the switch traffic, and we are right up around a gigabit actually going through the switch. So let me start a second client and see what happens there. Okay, so as tests start and go, we are definitely hitting almost 2 gigabits on the AP. So this says right here about 1600 megabits, and so that's kind of what I would expect. So for APs that are only dual band, so a lot of Wi-Fi 7 APs in the market now and Wi-Fi 6 APs don't include 6 gigahertz. And like I said earlier, the Wi-Fi Alliance has made this very confusing for us by branding 6 gigahertz devices in Wi-Fi 6 as 6E. But in Wi-Fi 7, they're just Wi-Fi 7. There's no E. So Wi-Fi 7 APs may only need gigabit because they might only be doing 5 gigahertz for high bandwidth. This guy is doing 6 gigahertz for high bandwidth and 5 gigahertz. So he can use almost 2 gigabits a second with clients. I could also add in 2.4 gig here. That's only 20 megahertz though, so it'd be a quarter of this traffic. It's like 200 megabits. It's not bad, but it's not getting us to need an upgrade above 2.5 gig to say 5 gig or 10 gig. So if you see an AP that actually does have 10 gig, it better have at least about 12 spatial streams or it's not going to be using that 10 gigabits per second. The third bullet I'm trying to find is what is their long-term commitment for these products like? How long are they going to continue firmware updates, etc. as new models come out? And I'll be honest, this is really hard to tell without having bought and used these products for years. So what I've decided to do is I've looked on Reddit and found evidence of people buying and installing access points many years in the past. Then I'm going to look at what models they bought and see what the support is like for that model right now. So here is their firmware upgrade page. It lists every model they've ever made and all their firmware updates. End-of-life products are at the bottom under end-of-life, and we can see what the last version of firmware for that model was. So here I found someone, it's 3 years ago, and someone also 3 years ago said they bought a bunch of 7660s, and that's the model number I'm starting with. So GWN7660, so looks like we have a couple of different models here. We have ELR, E, and then regular and LR. So at least they're adding suffixes when it changes. Let's see what the release note looks like for this guy. So he was updated January 2025. That's a month and a half ago. So it's still active support. So I'm not sure when that model came out, but it's been out for at least 3 years and still has active support. So that's one plus. Next one, it's again 3 years ago. He's got some 7630s, and I guess that's it. And sure enough, it is January 2025. So 2 pluses so far on 3-year-old stuff. I'm hoping for 6 years on my equipment, but let's see if I can find any stories that old. So here again, 3 years old, 7660s. And here he got a GWN7000 router and 7660 AP. Not sure when he bought them, but yeah, at least 3 years ago, maybe more. So I already looked at the 7660 and it's still supported. How about GWN70000? So that guy is down here in the end of life. His last version was this one. And his release note is from 2017. Is that the oldest? 7/6/2020. Okay, so that's at this point 4.5 years old on a product that launched 3 years before that. So 3 years support for the 7000. That's what I got so far. Pretty sure they abandoned their router line. Oh, okay, so they just gave up on routers entirely. Is that what happened? Well, they have routers now. 7001, okay. They just got rid of the 7000 router. Looks like they're still making some pretty old APs here. So like this guy, 7605, 7630, we saw someone got a couple years ago. 7660, I have the 7665. So they're not retiring these super quickly. So again, I don't know entirely what to make of this. I've obviously been using TP-Link equipment now for 7 years. They dropped support for me 3 years in, so I've been running APs without firmware upgrades for quite a long time now, which is not a good way to live. Hopefully Grandstream won't do that to me too. Guess we'll see. And my fourth requirement is that it supports IPv6 on the management network. So tested up here, I got the AP. I've got this line, which is 2.5 gig PoE back to my switch. I've also got 1 gig connected to a USB NIC to my laptop. That's just for me to manage the interface. I'm on my IPv6 only VLAN here, so I'm not carrying tagged traffic on this. This is just the IPv6 only network. I'm not doing VLAN tagging or anything like that right now. And let's see how management looks. So first up, I'm going to browse and see if it advertises itself. And there we go. So Grandstream GWN7665 web management for that MAC address, .http.tcp. So I can discover it, and then let's give it all the information. So it's got this super long domain name in DNSSD, and that corresponds to GWN-EC7D blah blah local, which obviously is good. So if we actually query that name now, we get back its IPv6 GUA. And also it's returning 0.0.0.0 over IPv4, which is probably a bug, but not a big one. So far so good. It's reporting itself over MDNS correctly. It has an IPv6, my v6 only network. How about the web UI? Web UI does not appear to have any problems. We are up. If I go over to the status page, we have no v4 address, so if I add the v6 address column, then it shows up there and looks fine. If I look at the detail information, let's see, we just have a blank for IPv4 and IPv6 looks fine. I get nothing in the alerts that would tell me it's having a networking problem. Now the only thing I can't test with this is I only have 1 unit, so it's the master. I can't really test slaving multiple units onto this over v6 only. So that's just not something, I only have 1 unit, I can't test that. But I hope it works. Everything else seems to work. So if I get more units, I'll update you guys. So where does that leave me with the Grandstream GWN7665, Wi-Fi 6E, and the 6 GHz band in general? I think some marketing people in the consumer Wi-Fi space are really spreading around some lies about what to expect from Wi-Fi 6, Wi-Fi 6E, and Wi-Fi 7. I know in theory the spec says you should be able to get like 23 gigabits from Wi-Fi 7 on 320 megahertz channels at 6 gigahertz with MLO and all this sort of stuff. You're never going to see that for any single client ever. So what does the 6 gigahertz band really get you, and do you actually need Wi-Fi 7 or or Wi-Fi 7 6 GHz, Wi-Fi 6E, Wi-Fi 6 without 6 GHz, etc. So in this particular access point here, and really quite a lot of access points, this does the same bandwidth in 6 GHz as it does in 5. So this can do 160 megahertz channels at MCS 11, this is 1024 QAM, and 6 GHz, 2x2 MIMO, and also in 5. So in theory, that's not any better, is it? Well, it is better if you have more than one device, and at least half of your devices, or at least a few of your devices, support 6 GHz. Because if I have some laptops in my house that do 6 gig, and some phones that don't, some of them end up on 5 gig, some of them end up on 6 gig, and it's less congested for everyone. Without even going to the higher frequencies, I'm not even going to 320 megahertz channels or things like that. That's just by adding a 6 gigahertz radio. Some of the clients will go to 6 gigahertz if they support it, and you're spreading your clients out across more radio spectrum, better experience for everyone. Now, if you're a small business, if you're hosting public Wi-Fi especially, this is something you should be all over. Public Wi-Fi, or general high-density Wi-Fi, tends to have a lot of problems with interference from just how many clients they have trying to connect to their APs. So adding 6 gigahertz, basically having 6 gigahertz on all of your APs that currently have 5, doubles your channel capacity. But it's even better than that because there's more channels available in 6 gig, so you're not having as much inter-AP interference, where two APs are broadcasting on the same channel. So that assumes your clients are actually capable of 6 gig, which some really new phones are. I have an iPhone 14, I think, and it does not do 6 gigahertz, but the newer ones do. So my recommendation is generally, if you're hosting Wi-Fi for more than just a couple of devices, you probably should be adding 6 gigahertz to your network next time you upgrade, but don't rush out and buy a new AP just to get 6 gigahertz. Now, as for the Grandstream AP itself, a couple positives, a couple negatives. First off, great IPv6 support, at least from what I found. Haven't had any issues now where something was IPv4 only. All of the boxes where I can enter configurations except IPv4 and IPv6 addresses. The UI allows me to show them both. I just have to change which columns are enabled. That's not a big deal for me. The central management via one access point is also a feature that I really like. So I don't have to host my own controller. I don't have to use a cloud controller. I can just get 4 of these APs, plug them in, and all talk to each other, and it's great. I am going to have a rough time when I start adding WPA3 to my network. So I did try to enable WPA3 on this guy on 2.45 and 6 gig in concert with my additional network, which is running WPA2. So clients should be able to roam between WPA2 and 3. However, I found many clients will not. So Apple, for example, once you connect to an AP that's WPA3, it will never go back to WPA2 with that same SSID because it thinks you're trying to do a downgrade attack. So it thinks someone's trying to spoof an access point with older, less secure WPA2 in order to steal your Wi-Fi password. And that totally makes sense. I get why Apple would do that. It just means now I have to upgrade all of my equipment to WPA3 so that I can enable the same SSID on 6 gigahertz. Or I have to have a different SSID in 6 gigahertz. And that probably would be fine too for all my Apple devices and Android devices and Windows PCs and stuff. But it's not fine for my IoT junk. And so that means I end up needing a separate IoT SSID. And I can't just do something like PPSK with radius, because I actually need to enable both WPA3 and WPA2, and I basically need another SSID with the AKMs for WPA2 and a separate one with the AKMs for WPA3. So what I'll probably end up doing is going to WPA3 SAE for all of my normal clients with the same SSID I have now on a mix of 5 and 6 gigahertz. Probably turn that off in 2.4. There's no real reason to do that. Maybe on the outside AP we'll enable 2.4. And then I'll make another SSID that has a different name that'll do on just 2.4 gigahertz for all my IoT junk, because I've got a lot of that. So I'm pretty happy with this guy. He's currently being sold, as of the making of this video, for $110. I think that's a very reasonable price for this thing. I also looked online, and they have a couple other form factors, not with 6 gigahertz, but with just 2.4 and 5. So one form factor that I really like is the wall form factor. It screws onto a wall box. Maybe put some B-roll here. And basically, you run the Ethernet into the back of it. PoE, you get Ethernet jacks out the bottom. Some of them have PoE out. You get a Wi-Fi access point. It's like 2x2 MIMO and 2.4 and 5 gigahertz. They're kind of designed for like hotels or apartment buildings or things like that, where you put one in every room. But I think they're a great form factor for houses too. So if you're doing residential Wi-Fi, I really like that form factor. If you follow my channel and do small business networking, this is probably the form factor you'd end up getting, the UFO style, but It's up to you. I do like too that Grandstream's wall mount APs aren't outrageously expensive. So one other brand in particular charges like twice as much for their wall mounted APs for no good reason. So that's Ubiquiti. So that's all I have to say really. This guy supports IPv6 really well, unlike Ubiquiti. It currently seems to function better than my TP-Link gear. My TP-Link gear, I'm mad at them because they don't do firmware upgrades. This particular unit and their Wi-Fi 5 units even still are doing firmware updates, so I'm happy with that for now. I'll have to keep watching it, of course. I am still open to trying other vendors for my new network in the future. MikroTik in particular has a really good management interface because I really like it. I know that's a very controversial topic. They don't do 6 gigahertz yet, so I don't have that option. Maybe if they did, I would try it out. But yeah, anyone else you want to let me know, I can reach out to them and see if I could test their products. And what else? I have a Discord server, link down below for that. You can chat with me about whatever you want, networking related, home server, stuff like that. I have a Ko-fi, link down below for that as well. Kind of like a Patreon where you give a tip, but it's only a one-time thing. I really appreciate those. And I think that's it. So as always, I'll see you guys on the next adventure.